When you multiply two matrices, unlike adding or subtracting, there's very different rules that apply. When you add or subtract matrices, you just have to make sure they're the same dimensions. When you multiply two matrices, that's not the case. Although having two of the same dimensions would be okay, there's more to it than that, and I'm going to show you in this video. So the question at first, before I actually get to doing the multiplication, and we're going to use the calculator to do the multiplication, they're going to ask us, is AB defined? Meaning, if we were to multiply matrix A times matrix B, would it be defined? Meaning, would there be an answer to it? And then if so, what would the dimensions be? We'll get to that in a second. So here's how it works. Let's take these two matrices, matrix A and matrix B. I have no idea what's in those matrices, but to tell whether it's defined, it doesn't matter what's in it. Here's what I want you to do. Write your two dimensions side by side, and make sure you put them in order, because that's going to be important, as you're going to see in a second. So a 3 by 4 matrix multiplied by a 3 by 2 matrix. So remember, that's rows first, so it's a 4-row matrix and a 3-column matrix, and then a 3-row matrix and a 2-column matrix. So we know that we would not be able to add these; they're not the same size. But it turns out that we actually can multiply them together. What needs to be true is that these two inner dimensions need to match up. They need to be the same number. In other words, the columns of matrix A needs to match up to the rows of matrix B. And as long as that's the case, you can go ahead and perform the operation. So yes, or if we multiply matrix A times matrix B, it would be defined for this example. They ask us what the dimensions of the answers would be, and it turns out that those leftover numbers, the 4 and the 2, would be the dimensions of my answer. So the answer would be a 4 by 2 matrix. And it's kind of interesting. We have two completely different size matrices, a 4 by 3 and a 3 by 2. We are allowed to multiply them together, and our answer is still a different dimension altogether. It's a 4 by 2. So multiplying is much more complicated than adding or subtracting. Now, I had said be careful that you do this in the right order, because watch what would happen. Suppose I put the dimensions of matrix B down first, so a 3 by 2. And then a 4 by 3. Well, the rule is that these inner two numbers need to match up, and if I switch the order, it doesn't. So again, matrix multiplication is very, very different. We're used to multiplication not mattering. You know, you can flip the order of numbers, and who cares what order you multiply numbers in. But matrices, it does matter. It works one way, but it does not work the other way. So just be careful about that. But that was just a little side note. Anyway, back to our second example. Is A times B defined? So to figure that, again, I like to write my dimensions side by side. So it's a 3 by 4 multiplied by a 3 by 2 matrix, and in order for the multiplication to work, in other words, to be defined, those inner two numbers need to match up. In this case, they don't, so we cannot do the multiplication. It will not work. Once I show you how to do this on the calculator, you could try typing a 3 by 4 and a 3 by 2. It'll give you an error message. You're not going to be able to multiply those together. So let's go ahead and actually take a look at how that process is going to work. So I have this slide where we've multiplied matrix A times matrix B. I've given you two matrices to start with. And I guess the first thing that we should do is make sure the multiplication would work. These are both 2 by 2 matrices. So it's a 2 by 2 and another 2 by 2, and I told you that these inner two numbers need to match up, and this time they do, so the multiplication will work out. And then my answer matrix will be the size of those leftover numbers, so my answer will be another 2 by 2. So kind of like adding or subtracting in this case, everything stays the same dimension. Now I'm not going to go through too much detail about how this works by hand, because I just want to use my calculator, but what we're doing is we're multiplying an entire row, this 1 by 4 row, by this first column, the 5 by 9 column, and I've kind of written down my work down here. So that entire row, I've started with 1 times 5. I'm going to add that to 4 times 9, and I kind of have to, I don't really want to do this by hand. So since the calculator will always be able to do this faster and more accurately than we ever can, let's go ahead and use the calculator to actually do this multiplication. Let's not be too concerned about where these numbers all came from. I don't really care. I just want you to be able to do the multiplication at this point. So let's switch over and do that, and then we'll answer an interesting question too. Is matrix multiplication commutative? In other words, can I flip the order? And I kind of already showed you in that last example what could go wrong, but we'll use the calculator and see that even though the order wouldn't, or the multiplication will work in any order, you'll see that we may not be getting the same answer if we do that. So let's break from doing this by hand. Let's switch over to our graphing calculator and let that do this multiplication for us.